Hello students, let us deal with a chapter what is called as bipolar junction transistor, in short which is represented as BJT. So this transistor or BJT is the building block of all the electronics revolution. ಈ BJT ಒಂದ್ಸರಿ ಕಂಡಿಡಿದಾದ ಮೇಲೆ the electronics was taken into a new era, and the scientist who found out this BJT or the transistor was Shockley, Breton and Bardeen. These are the scientists, these three from the Bell Laboratory found out this transistor. So after the invention of this transistor, this was mainly used in almost all of the electronic goods what we are going to use in our daily life. That can either be a simple mobile phone or a television or a refrigerator, whatever it is. So the two main important application of this transistor is it is used as an amplifier and it is used as a switch. So we are going to study in detail about this transistor as an amplifier in our second PUC, and now let us just try to see the basics of this BJT. So what is this BJT? BJT, as I told you, BJT stands for bipolar junction transistor, and this transistor is a three-terminal device. Three-terminal device, unidirectional current conducting device. Unidirectional, uni stands for one side, right? Unidirectional current conducting device. So the current conducts in only one direction. And why the name bipolar? Bipolar anta ಏನಕ್ಕೆ ಕರಿತೀವಿ? Here bi stands for two. So bipolar meaning both the majority charge carriers and the minority charge carriers. So the current conduction in this transistor is because of both the majority charge carriers and the minority charge carriers. ಹಾಗಾಗಿ ಇದಕ್ಕೆ ಹೆಸರು bipolar. So what is this BJT? BJT is a three-terminal unidirectional current conducting semiconductor device, and the name bipolar comes from the fact that the current conduction is due to both the majority and the minority charge carriers. And this transistor or the BJT is nothing but the combination of two diodes which are connected back to back. ಎರಡು diodes na back to back connect ಮಾಡಿದ್ರೆ we are going to get what is called as a transistor. And the important application of this transistor is it can be used as an amplifier and a switch. So what are the three terminals of a transistor? The three terminals of a transistor are emitter, base and the collector. Emitter, base and the collector are the three terminals of a transistor. Emitter is represented by E, capital letter E. Base is represented by capital letter B and collector is represented by capital letter C. And three terminal device ಅಂತ ಹೇಳೋದ್ರಿಂದ ನನಗೆ the representation of this transistor is like this. The symbol of a transistor is like this. Here transistor ಅಂದಿದ ತಕ್ಷಣ ನನಗೆ ಎರಡು ಟೈಪ್ ಬರುತ್ತೆ. One is NPN type of transistor, the other one is PNP type of transistor. In an NPN type of transistor, what is this NNP? NNP are nothing but different types of semiconductors. N type of semiconductor and P type of semiconductors. In an NPN type of transistor, P type of semiconductor is sandwiched between two N type of semiconductor. Andre ಮಧ್ಯದಲ್ಲಿ I'll be having one P type and ಎರಡು N type ನನಗೆ P ಅಕ್ಕಪಕ್ಕ ಇರುತ್ತೆ. So this terminal will be called as the emitter, this will be called as the base and this will be called as the collector. Similarly, in PNP type of semiconductor, PNP type of transistor, N type is sandwiched between two P type. So ಅದನ್ನ ಈ ತರ represent ಮಾಡ್ತೇವೆ, PNP. So this will be the emitter terminal, this will be the base terminal and this will be the collector terminal. And the symbolic representation of these transistors are this. ಈ ತರ represent ಮಾಡ್ತೀವಿ, ಈ ತರ. This is ಇಲ್ಲಿ ಒಂದು ಸರ್ಕಲ್ ಹಾಕ್ತೀವಿ. This is the base terminal, this is the emitter terminal and this is the collector terminal. But ಇದರಲ್ಲಿ NPN ಯಾವುದು PNP ಯಾವುದು ಅಂತ ಡಿಸೈಡ್ ಮಾಡೋದು. This is the collector terminal, base, emitter and the collector. We are going to put an arrow mark on the emitter line. If the arrow mark is facing towards the emitter, then that is NPN type of transistor anta artha. If the arrow mark is facing towards the straight line or towards the base, that is away from the emitter, then that is PNP type of transistor. This is the symbolic representation of these transistor. NPN type and PNP type anta ಎರಡು ಥರ ಇದೆ. In NPN type of transistor, P type of semiconductor is sandwiched between two N types, and in PNP type of transistor, N type of semiconductor is sandwiched between two P types of semiconductors. And these are the symbolic representation. Symbolic representation, the arrow mark decides which type of transistor it is anta. If arrow mark is facing towards the emitter, then it is NPN. If arrow mark is moving away from the emitter, then it is PNP type of transistor. And what are the functions of these terminals of a transistor? Emitter ಗೆ ಏನು ಕೆಲಸ, ಬೇಸ್ ಗೆ ಏನು ಕೆಲಸ, ಕಲೆಕ್ಟರ್ ಗೆ ಏನು ಕೆಲಸ. ಎಮಿಟರ್ ಏನು ಕೆಲಸ ಅಂತ ಹೇಳಿದ್ರೆ, and here one thing you have to remember, emitter is heavily doped region out of all these three. Heavily doped region ಅಂತಂದ್ರೆ more number of impurity atoms are added to the emitter terminal, and base anta ಹೇಳಿದಾಗ it is lightly doped region, and whereas the collector, it is moderately doped region. Emitter is a terminal, or emitter is a layer which is heavily doped, base is a layer which is lightly doped, and collector is a layer which is moderately doped. Coming to the physical size of these three terminals, collector size is very large. The physical dimension of collector is large, and emitter is medium in size, and base is narrow in size. So ಹಾಗಾಗಿ ನಾವು ಇದನ್ನ represent ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದಾಗ, the collector terminal will be very large in size, base terminal will be very narrow, and the emitter terminal will be bigger in size. So these are the three terminals. From each of these types, idu NPN or PNP, whatever it is, let me consider that it is an NPN type of transistor. This is emitter terminal, base terminal, and the collector terminal. So collector region is very large, base region is very narrow, and emitter region is medium in size. Whereas coming to the doping levels, emitter region is heavily doped, base region is lightly doped, and the collector region is moderately doped. And what is the functions of these emitter, base, and the collector terminals of a transistor ಅಂತ ಹೇಳಿದ್ರೆ, emitter is nothing but a terminal of a transistor which supplies the charge carriers to the collector, which supplies the majority charge carriers to the collector. Emitter ಇಂದ collector ಗೆ supply ಮಾಡುತ್ತೆ, emitter ಇಂದ collector ಗೆ charge carriers movement ಆಗುತ್ತೆ, and that is only because of the emitter terminal. So emitter is nothing but a terminal which supplies, and base ಏನು ಮಾಡುತ್ತೆ, base is nothing but it is a region which transfers. emitter supply ಮಾಡುತ್ತೆ, base transfer ಮಾಡುತ್ತೆ, it transfers the majority charge carriers which is sent from the emitter terminal to the collector. And what does this collector do? Collector collects the majority charge carriers which is coming from the base. So these are the three functions of a transistor, three terminals of a transistor. What is the function of an emitter? Emitter supplies the majority charge carriers to the collector, base transfers the majority charge carriers from the emitter to the collector, and collector collects the charge carriers or collect the majority charge carriers ಅಂತ ಹೇಳ್ಬೋದು. ಓಕೆನಾ? and ಇಲ್ಲಿ ನನಗೆ NPN ಅಂತ ಹೇಳಿದಾಗ, between these N and P I am having one junction, and between this P and N I am having another junction, and the junction which is present between the emitter to base terminal is called as emitter base junction, and the junction which is present between the collector to base is called as collector base junction. ಆಯ್ತಾ? ಇದನ್ನು ಚೆನ್ನಾಗಿ ನೆನಪಿಟ್ಕೋಬೇಕು. ಸೊ emitter to base ಮಧ್ಯ ಇರುವಂತ ಒಂದು ಜಂಕ್ಷನ್ emitter base junction ಅಂತ ಕರಿತೀವಿ, and collector to base junction ಮಧ್ಯದಲ್ಲಿ ಇರುವಂತ collector to base terminal ಮಧ್ಯೆ ಇರುವಂತ junction ನ collector to base junction ಅಂತ ಕರಿತೀವಿ. And it is a usual practice to forward bias the emitter base junction and reverse bias the collector base junction. In such a case, forward bias ಆಗಿರುವಂತ emitter base junction offers very low resistance, and reverse bias ಆಗಿರುವಂತ collector base junction offers very high resistance. ಆಯ್ತಾ? forward bias ಅಲ್ಲಿ ಕರೆಂಟ್ ಚೆನ್ನಾಗಿ ಫ್ಲೋ ಆಗ್ತಾ ಇರುತ್ತೆ, ಸೊ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ ಲೆಸ್. ರಿವರ್ಸ್ ಬಯಾಸ್ ನಲ್ಲಿ ಕರೆಂಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ಫ್ಲೋಯಿಂಗ್, ಸೊ ದ ಕರೆಂಟ್ ಐಡಿಯಲಿ ಹೇಳೋದಾದ್ರೆ ರಿವರ್ಸ್ ಬಯಾಸ್ ನಲ್ಲಿ ಕರೆಂಟ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು 0, ಬಟ್ ಸ್ಟಿಲ್ there will be small amount of minority charge carriers in the current ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ. ಸೊ ಕರೆಂಟ್ ಇರೋದ್ರಿಂದ ನನಗೆ ಸ್ವಲ್ಪ ಅಮೌಂಟ್ ಆಫ್ ಕರೆಂಟ್ ಇರೋದ್ರಿಂದ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಹೈ. ಸೊ ದಿಸ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್, ಇನ್ನೊಂದು ಮೀನಿಂಗ್ ಹೇಳೋದಾದ್ರೆ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಪ್ಲಸ್ ರೆಸಿಸ್ಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ರೆಫರ್ಸ್ ಟು ದ transfer of charge carriers from low resistance region to high resistance region. That is what is the meaning of this transistor, transfer of resistor. So it is nothing but the transfer of charge carriers from low resistance region to high resistance region. Next we are going to see what is called as unbiased NPN transistor. Unbiased NPN transistor ಅಂತ ಹೇಳಿದ್ರೆ, here I am having a transistor. ಇಲ್ಲಿ ನನಗೆ ಕಲೆಕ್ಟರ್ ಟರ್ಮಿನಲ್ and ಇಲ್ಲಿ ಬೇಸ್ ರೀಜನ್, ಬೇಡ ಇನ್ನೊಂದು ಡಯಾಗ್ರಾಮ್ ಬರೀತೀನಿ. Collector region, collector terminal is large in size, base region is very small in size, and this is the emitter, this is the base, and this is the collector, NPN. So as we have already seen in the semiconductor chapter, lightly doped iro kade, the width of the depletion region is very large. The width of the depletion region is very large. ಈ ಎಮಿಟರ್ ಮತ್ತು ಕಲೆಕ್ಟರ್ ಮತ್ತು ಬೇಸ್ ಜಂಕ್ಷನ್ ಮಧ್ಯದಲ್ಲಿ ದ ಬೇಸ್ ಇಸ್ ದಟ್ ಲೇಯರ್ ವಿಚ್ ಇಸ್ ಲೈಟ್ಲಿ ಡೋಪ್ ಕಂಪೇರ್ಡ್ ಟು ಕಲೆಕ್ಟರ್. ಸೊ ಇಲ್ಲಿ ನನಗೆ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ವಿಡ್ತ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಕಂಪೇರ್ಡ್ ಟು ದಿಸ್ ಸೈಡ್. ಅದೇ ಇವೆರಡರಲ್ಲಿ ಕಂಪೇರ್ ಮಾಡಿದೆ, ಎಮಿಟರ್ ಮತ್ತು ಬೇಸ್ ಸೈಡ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಎಮಿಟರ್ ಇಸ್ ಹೆವಿಲಿ ಡೋಪ್, ಸೊ ದ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ದ ವಿಡ್ತ್ ಕಡಿಮೆ ಇರುತ್ತೆ ಕಂಪೇರ್ ಟು ದ ವಿಡ್ತ್ ಆಫ್ ದ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಟುವರ್ಡ್ಸ್ ದ ಬೇಸ್. ಡಯಾಗ್ರಾಮ್ ಅಷ್ಟು ನೀಟಾಗಿ ಬರಲಿಲ್ಲ, ಇಲ್ಲಿ ನೋಡಿ. In an NPN type of transistor, the emitter NPNR agli PNPNR agli, the emitter is a layer which is heavily doped, and collector is a layer which is moderately doped, and base is a layer which is lightly doped. Base ಇವೆರಡನ್ನ ಮಾತ್ರ ನೋಡಿದಾಗ, ಬೇಸ್ ಮತ್ತು ಕಲೆಕ್ಟರ್ನ ನೋಡಿದಾಗ ಕಂಪ್ಯಾರಿಟಿವ್ಲಿ base is lightly doped. So the width of the depletion region is more towards the base compared to the collector. ಮತ್ತೆ ಇದನ್ನ ನೋಡಿದಾಗ emitter and base junction ನೋಡಿದಾಗ, since emitter terminal is heavily doped, the width of the depletion region is very less compared to the width of the depletion region towards the base. So ಹೀಗೆ ನನಗೆ unbiased NPN transistor ಅಂತ ಹೇಳಿದ್ರೆ I have not connected any external source to the terminals of these transistor. ಅದನ್ನ ನಾವು unbiased ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? ಸೊ ನಾನು ಹೇಳಿದೆ the transistor will be used for two different applications. One is as an amplifier, the other one is as a switch. So amplifier ಅಂತ ಹೇಳಿದಾಗ I am having three different terminals of a transistor. So ನನಗೆ ಎರಡು ಜಂಕ್ಷನ್ ಇದೆ, ಒಂದು ಎಮಿಟರ್ ಬೇಸ್ ಜಂಕ್ಷನ್, let me write it in short as EB junction, and the collector base junction. What is the application ಅಂತ ನೋಡೋಣ, ಆಯ್ತಾ? When the emitter base junction is forward biased and the collector base junction is reverse biased, the transistor will be acting like a amplifier, ಆಯ್ತಾ? ಇನ್ನೊಂದು ಕೇಸು, when both of these junctions are forward biased, the transistor will be acting like a switch, that is on switch ಅಥವಾ closed switch ಅಂತ ಹೇಳ್ಬೋದು. And when both of these junctions are reverse biased, again the transistor will be acting like a switch which is in the off state or open switch ಅಂತ ಹೇಳ್ಬೋದು. ಓಕೆನಾ? So these are the three different applications ಅಂದ್ರೆ ಇವೆರಡು ಸ್ವಿಚ್ ಇದೇನೆ, ಬಟ್ ಸ್ವಿಚ್ಗೆ ನನಗೆ ಎರಡು ಥರ ಕೆಲಸ ಮಾಡ್ಬೋದು. ಒನ್ ಇಸ್ ದ ಸ್ವಿಚ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್ ಆಸ್ ಅನ್ ಆಫ್ ಸ್ವಿಚ್ ಆ್ಯಂಡ್ ಅನ್ ಆನ್ ಸ್ವಿಚ್. ಸೊ ಎರಡೂ ಜಂಕ್ಷನ್ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಆದಾಗ ದಟ್ ವಿಲ್ ಬಿ ಆ್ಯಕ್ಟಿಂಗ್ ಲೈಕ್ ಅ ಕ್ಲೋಸ್ ಸ್ವಿಚ್. ಎರಡೂ ಜಂಕ್ಷನ್ ರಿವರ್ಸ್ ಬಯಾಸ್ ಆದಾಗ ದಟ್ ವಿಲ್ ಬಿ ಆ್ಯಕ್ಟಿಂಗ್ ಲೈಕ್ ಅ ಓಪನ್ ಸ್ವಿಚ್. ವೆನ್ ಒನ್ ಆಫ್ ದ ಜಂಕ್ಷನ್, ದಟ್ ಈಸ್ ಎಮಿಟರ್ ಬೇಸ್ ಜಂಕ್ಷನ್, ಒನ್ ಆಫ್ ದ ಜಂಕ್ಷನ್ ಅಲ್ಲ, When emitter based junction is forward bias and collector based junction reverse bias ಆಯ್ತು ಅಂತಂದ್ರೆ transistor will be acting like an amplifier. So now let us see how the NPN transistor works. That is working of NPN type of transistor ನೋಡೋಣ ಆಯ್ತಾ. So as I told you, this is NPN type of transistor. ಇಲ್ಲಿ let us consider that the emitter base junction, this is the emitter terminal and this is the base terminal and this is the collector terminal. The emitter base junction is forward bias and the P type will be connected to positive terminal of the battery and N type is connected to negative terminal of the battery. Similarly, the collector base junction ಅಂತ ಏನಿದೆ ಅದನ್ನ ನಾವು reverse bias connect ಮಾಡೋಣ. P type is connected to negative, N type is connected to positive. So this is the diagram what we are going to see to understand the working of an NPN type of transistor. So as soon as the emitter base junction is forward biased, the electrons which are present in the N side, that is the emitter terminal, they get repelled towards they start to move towards the base. Since the emitter is heavily doped, a number of electrons starts moving from the emitter towards the base, and in the base region, since it is lightly doped, we are going to see only a few number of electrons coming from the emitter will recombine with the holes which are present in the base, and the remaining electrons will reach the collector region. So as soon as the electron starts moving from the emitter to base junction, emitter to base terminal, there occurs a current what is called as IE, and only a few number of electrons will recombine with the holes which are present in the base terminal, leading to the current what is called as IB, and the remaining electrons will be collected in the collector terminal, and ಅಲ್ಲಿ ನನಗೆ ಇನ್ನೊಂದು current ಕಾಣಿಸ್ಕೊಳ್ಳುತ್ತೆ IC. So we can write this as IE is equal to IB plus IC. IE ಎಷ್ಟಿರುತ್ತೋ ಅಕಾರ್ಡಿಂಗ್ ಆಗಿ ಬೇಸ್ ಕರೆಂಟ್ ಮತ್ತೆ ಕಲೆಕ್ಟರ್ ಕರೆಂಟ್ ಇರುತ್ತೆ. ಇಷ್ಟೇನೆ ನಾವು ವರ್ಕಿಂಗ್ ಆಫ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಅಲ್ಲಿ ಹೇಳೋದು. IE is nothing but the emitter current will be equal to the sum of the base current and the collector current ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆನಾ? After this we are going to see the different configurations. ಏನಿದು configurations ಅಂತ ಹೇಳಿದಾಗ I told you that the emitter base junction and the collector base junction has to be biased separately. ನಮಗೆ biasing ಕೊಡಬೇಕು ಅಂದ್ರೆ separate ಆಗಿ bias ಮಾಡಬೇಕು. biasing ಮಾಡಬೇಕಾದ್ರೆ ಈ ಎರಡು ಜಂಕ್ಷನ್ಗೆ ನನಗೆ at least ಎರಡು ಟರ್ಮಿನಲ್ಸ್ ಬೇಕು in order to connect a power supply, and for these two junctions and for this junction ಈ ತರ source connect ಮಾಡಬೇಕು ಅಂದ್ರೆ again separate two terminals ಬೇಕು. So for this I need two terminals, for this I need two terminals, so totally I want four terminals, but here in the transistor I am having only three terminals. So what we are going to do is we are going to make one of the terminal as common for input as well as output. ಅದನ್ನೇ ನಾವು different configurations ಅಂತ ಕರಿತೀವಿ. Likewise we are having three different configurations. One is common base configuration, the other one is common emitter configuration, and the last one is common collector configuration. Common base is represented by CB, common emitter by CE, and common collector by CC. So these are the three different configurations of a transistor. In the common base configuration, the base terminal is made common for the emitter for the input as well as the output. For the common emitter terminal is made common for the input as well as the output. In the common collector configuration, collector terminal is made common for input and the output. So let us try to understand that with the help of this diagram. This is a common base configuration where the base terminal is made common. Base terminal common ಮಾಡಿ we are going to apply the input between the emitter and base, and that voltage will be represented by emitter to base voltage, which is called as VEB, and the output is taken between the collector and the base, and that will be represented by VCB, collector to base voltage. So here a base terminal is made common for both input as well as the output. Coming to common emitter configuration, your emitter terminal will be made common for both input as well as the output. Emitter terminal common ಮಾಡಿದಾಗ base will be applied between the emitter and the base, whereas the output will be input will be applied between the base and the emitter, whereas the output will be applied between the collector and the emitter. So the input voltage is nothing but VBE, that is base to emitter voltage, and the output is nothing but the collector to emitter voltage. So here emitter is made common, ಅಥವಾ ಇದನ್ನ ನಾವು grounded emitter configuration ಅಂತ ಕೂಡ ಕರಿತೀವಿ. ಕಾಮನ್ ಬೇಸ್ನ ಗ್ರೌಂಡೆಡ್ ಬೇಸ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಂತ ಕೂಡ ನಾವು ಕರಿತೇವೆ. And this type of transistor is most widely used in the amplifier circuits, whereas this common base configuration na high frequency response ಗಳಲ್ಲಿ, high frequency circuits ಗಳಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೇವೆ. Coming to the last one, that is common collector, where the collector terminal, this is the base terminal, emitter terminal and the collector terminal. ಇಲ್ಲಿ arrow mark ನೋಡಿ, arrow mark ಯಾವ ಕಡೆ ಇದೆಯೋ that terminal ಅದು emitter ಅಂತ. So here collector terminal will be made common for both input side as well as the output side. So base and collector madhyadalli we are going to connect the input, which will be represented as VBC, base to collector voltage, and the output will be extracted between the two terminals, emitter and the collector, and that is represented as VEC, collector to emitter voltage anta ಹೇಳ್ತೇವೆ. After this we are having DC current gain of a transistor. ಎರಡು ಗೇನ್ಗಳು ಕಾಣಿಸುತ್ತೆ in the CB mode ಅಂತ ಹೇಳಿದ್ರೆ in the common base mode I'll be having a current gain is nothing but gain ಅಂತ ಹೇಳಿದ್ರೆ it is nothing but output divided by input. ಅದೇ current gain ಅಂತ ಹೇಳಿದ್ರೆ output current divided by input current. In terms of voltage gain ಅಂತ ಹೇಳಿದ್ರೆ voltage gain ಅಂದ್ರೆ output voltage divided by input voltage. Power gain output power divided by input power ಅಂತ ಹೇಳ್ತೇವೆ. So in the CB ಅಂತ ಹೇಳಿದ್ರೆ common base mode, the current gain will be represented by alpha, and that is equal to IC divided by IE. Common base terminal ಅಲ್ಲಿ the output will be extracted between the collector and the base. Input will be applied between the emitter and the base. So output current is represented by IC, input current is represented by IE. So output current IC by IE is nothing but alpha anta ಹೇಳ್ತೀವಿ. Similarly, in the common emitter configuration, the current gain will be denoted by beta, and that is equal to IC divided by IB. This you have to remember. ಇದನ್ನ ಕೇಳ್ತಾರೆ. In the common emitter configuration, the emitter terminal is made common for the both input as well as the output. ಇಲ್ಲಿ output is extracted between the collector and the ground. So output current is represented by IC and input current is represented by IB. So IC divided by IB anta ಆಗುತ್ತೆ. Okay na? Now this is the current amplification factor ಅಂತನಾದರೂ ಕರಿತೀವಿ ಅಥವಾ current gain ಅಂತನಾದರೂ ಕರಿತೀವಿ. Okay? Define current amplification factor of the CB mode ಅಂತ ಕೇಳ್ಬೋದು, or define alpha in the CB mode ಅಂತ ಕೇಳ್ಬೋದು. It is the ratio of collector current to the emitter current. Define beta ಅಂತ ಹೇಳಿದ್ರೆ it is the ratio of collector current to the base current. Now we have to derive the relationship between alpha and beta. Relationship between alpha and beta. We know that alpha is equal to IC by IE and beta is equal to IC by IB. Okay, let us consider this. Alpha is equal to IC by IE anta ತಗೋಣ. And just now we had also come across with this equation, IC is equal to IB plus IC. So IE is equal to IB plus IC. So IE ಜಾಗನಲ್ಲಿ let me substitute that IB plus IC. So now let us try to divide both the numerator and denominator by IB. So alpha is equal to IC by IB. ಇಲ್ಲಿ IB plus IC divided by IB anta. So let me split this. IC by IB is equal to IB by IB 1 anta ಆಗುತ್ತೆ, ಇಲ್ಲಿ IC by IB anta ಆಗುತ್ತೆ. But what is this IC by IB? IC by IB is equal to beta. So beta divided by 1 plus beta. So this is the relationship between alpha and beta. Alpha is equal to beta divided by 1 plus beta. Similarly, we are going to get the relation beta is equal to alpha divided by 1 minus alpha. ಈ ಎರಡು ರಿಲೇಶನ್ಶಿಪ್ ನ ನಾವು ನೆನಪಿಟ್ಕೋಬೇಕು. ಓಕೆನಾ? Now we are going to see the transistor characteristics. Characteristics ಅಂತಂದ್ರೆ ಏನಿಲ್ಲ, it is nothing but how the transistor voltage will how the transistor will behave ಅನ್ನೋದನ್ನ ನಾವು ಒಂದು ಗ್ರಾಫ್ ಅಲ್ಲಿ ನೋಡಿ represent ಮಾಡ್ತೀವಿ. So likewise here I am having two characteristics. One is the input characteristics and the output characteristics. So characteristics na draw ಮಾಡಕ್ಕೆ we are going to use this circuit diagram. ಈ circuit diagram na ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. And if you look into the circuit diagram, here the emitter terminal is made common. So this is the common emitter configuration. So input na apply ಮಾಡ್ತಾ ಇದ್ದೀವಿ with using a separate voltage source. Voltage source ಅಂದ್ರೆ here we are going to use RPS. ನಾವು lab ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದೀವಲ್ಲ ಅದು VBB. And output ನು ಕೂಡ ನಾವು vary ಮಾಡ್ತೀವಿ. ಅಲ್ಲಿ ನಾವು VCC, I mean again we are going to use a separate RPS. So ಇಲ್ಲಿ we are using two ammeters and VBE and VCE are nothing but voltmeters. Apart from that, we are going to use two resistors. One is the base resistor, the other one is the collector resistor. So, ಇದು ಏನಾಗುತ್ತೆ ಅಂತ ನೋಡೋಣ. First of all, let us try to understand what is this input characteristics. Input characteristics ಅಂತ ಹೇಳಿದ್ರೆ, we are going to vary this VCC ನ ವೇರಿ ಮಾಡಿ VCE ನ ಒಂದು ವೋಲ್ಟೇಜ್ಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಸೆಟ್ ಮಾಡಿ ಬಿಟ್ಬಿಡ್ತೀನಿ. With the help of this VCC, I am going to set this VCE to some value and maintain it as constant. Next ನಾನು ಇದನ್ನ ಮುಟ್ಟಲ್ಲ. Next ಏನ್ ಮಾಡ್ತೀನಿ, for different values of VBE, I'll be plotting IB value. I mean ಬೇರೆ ಬೇರೆ 0.1 VBE ನ 0.1 ಗೆ ಸೆಟ್ ಮಾಡ್ತೀನಿ. ಆಗ IB ವ್ಯಾಲ್ಯೂ ಏನು ಬರುತ್ತೆ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊತೀನಿ. Next VBE will be set to 0.2, then I'll note down IB. So ಈ ತರ for different values of VBE, I'll be noting down the values of IB. And VBE ನ ಹೇಗೆ ಸೆಟ್ ಮಾಡೋದು, with the help of this RPS, that is with the help of this VBB. ಆಯ್ತಾ? So ಈ ತರ ಪ್ಲಾಟ್ ಮಾಡಿ ಆದ್ಮೇಲೆ I am going to draw a graph of VBE versus IB, taking VBE on the x-axis and IB on the y-axis for a constant value of VCE. ಆಯ್ತಾ? ಗ್ರಾಫ್ ನ ಈ ತರ ಪ್ಲಾಟ್ ಮಾಡಿದಾಗ ನನಗೆ ಹೀಗೆ ಬರುತ್ತೆ. So looking into this graph, we can tell that it is same as that of the forward characteristics of a semiconductor diode. So input characteristics will be same as that of forward characteristics of a semiconductor diode. ಆಮೇಲೆ ನಾನಿಲ್ಲಿ RI ನ ಕಂಡುಹಿಡಿಯಬಹುದು by calculating the slope. ನಾವು forward characteristics of semiconductor diode ದಲ್ಲಿ ಗ್ರಾಫ್ ನ ಪ್ಲಾಟ್ ಮಾಡಿ ಸ್ಲೋಪ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಲ್ಲ, ಐ ಮೀನ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಲ್ಲ, ಫಾರ್ವರ್ಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್, ಅದೇ ತರ RI ವ್ಯಾಲ್ಯೂನ ಕಂಡುಹಿಡಿಯಬಹುದು. ನೆಕ್ಸ್ಟ್ ಕಮಿಂಗ್ ಟು ಔಟ್ಪುಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್. ಏನಿದೆ ಔಟ್ಪುಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ವಿಲ್ ಬಿ ವೇರಿಯಿಂಗ್ ಔಟ್ಪುಟ್ ಮೇಂಟೈನಿಂಗ್ ಇನ್ಪುಟ್ ಆಸ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ. ಔಟ್ಪುಟ್ ನ ವೇರಿ ಮಾಡ್ತಾ ಇನ್ಪುಟ್ ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರ್ತೀವಿ. ಬಟ್ ಇಲ್ಲಿ we are going to vary this VBB and will maintain a constant IB value. IB ನ ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂಗೆ ಸೆಟ್ ಮಾಡ್ಬಿಟ್ಟು ಕಾನ್ಸ್ಟೆಂಟ್ ಮಾಡ್ಬಿಡ್ತೀನಿ. ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ವೇರಿ ಮಾಡಲ್ಲ. With the help of this, I'll set this IB value to some constant value. ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂಗೆ ಸೆಟ್ ಮಾಡಿ ಅದನ್ನ ಬಿಟ್ಬಿಡ್ತೀನಿ. ನೆಕ್ಸ್ಟ್ ಐ ಆಮ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ವೇರಿ ದಟ್. Okay, later on I'll be setting different values of VCE and ಅದರದ್ದು ಕರೆಸ್ಪಾಂಡಿಂಗ್ IC ವ್ಯಾಲ್ಯೂನ ನಾವು ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. ಹೇಗೆ VCE ನ ವೇರಿ ಮಾಡೋದು, ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ VCC. ಈ RPS ನಾವು ಡಯೋಡ್ಗೆ ಸೆಟ್ ಮಾಡಿದ್ವಲ್ವ, ನೆನಪಿದ್ಯಾ? 0.1 ವೋಲ್ಟ್ಸ್, 0.2 ವೋಲ್ಟ್ಸ್, 0.3 ವೋಲ್ಟ್ಸ್ RPS ನ ವೇರಿ ಮಾಡಿ ಡಯೋಡ್ ಅಲ್ಲಿ ಇರುವಂತ ವೋಲ್ಟ್ ಮೀಟರ್ 0.1, 0.2ಗೆ ಸೆಟ್ ಮಾಡಿ ಅದನ್ನ ಆಮ್ಮೀಟರ್ ರೀಡಿಂಗ್ ನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಅಂತ ಹೇಳಿದೆ. ಅದೇ ತರ ಇಲ್ಲಿ VCE ನ 0.1 ವೋಲ್ಟ್ಸ್ ಸೆಟ್ ಮಾಡ್ತೀನಿ, IC ವ್ಯಾಲ್ಯೂ ಏನು ಬರ್ಕೋತೀವಿ. Again, I said that VCE 2.2 volts with the help of this VCC and note down that IC value. Likewise, after for different values of IB, I'll be getting this graph. ನನಗೆ ಬೇರೆ ಬೇರೆ IB ವ್ಯಾಲ್ಯೂಗೆ ಈ ತರ ಗ್ರಾಫ್ ಸಿಗುತ್ತೆ. Output characteristics is nothing but a graph which is plotted between VCE and IC taking different values of IB. ಒಂದು IB ವ್ಯಾಲ್ಯೂಗೆ ನಾನು ಈ IB ವ್ಯಾಲ್ಯೂ ತಗೋತೀನಿ, ಫಸ್ಟ್ IB ನ 0 ಅಂತ ಇಟ್ಕೋತೀನಿ. ನೆಕ್ಸ್ಟ್ IB ವ್ಯಾಲ್ಯೂನ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ, IB 1 ಅಂತ ತಗೋಣ. ನೆಕ್ಸ್ಟ್ ಫಾರ್ ಅನದರ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ IB ಐ ವಿಲ್ ಬಿ ಟೇಕಿಂಗ್ VCE and IC ಬೇರೆ ಬೇರೆ ಹೊಸ ವ್ಯಾಲ್ಯೂ. ಸೊ I'll be getting a number of curves for different values of IB and ಈ ಗ್ರಾಫನ್ನೇ ನಾವು ಔಟ್ಪುಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆನಾ? ಈ ಔಟ್ಪುಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅಲ್ಲಿ ನನಗೆ 3 ರೀಜನ್ ಬರುತ್ತೆ. ಏನದು 3 ರೀಜನ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಒನ್ ಇಸ್ ದ ಕಟ್ ಆಫ್ ರೀಜನ್, ದ ಅದರ್ ಒನ್ ಇಸ್ ಆಕ್ಟಿವ್ ರೀಜನ್ and the last one is saturation region. Cut off region ಅಂತಂದ್ರೆ the region which lies below IB is equal to 0, that region is called as cut off region. Idu cut off region. And the region where the response is almost a straight line, ಎಲ್ಲಿ ತನಕ ನನಗೆ ಒಂದು ಆಲ್ಮೋಸ್ಟ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ಸ್ ಬರುತ್ತೋ ಫಾರ್ ಡಿಫ್ರೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ IB, ಆ ರೀಜನ್ ನಾವು ಸ್ಯಾಚುರೇಷನ್ ರೀಜನ್ ಅಂತ ಕರಿತೀವಿ. And the region which lies above the cutoff region and next to the saturation region, this entire region will be called as the active region. So active region, saturation region and cutoff region. So ಇವಾಗಷ್ಟೇ ನಾನು ಹೇಳಿದೆ, ಈ cutoff region ಅಂತ ಹೇಳಿದ್ರೆ ಎಮಿಟರ್ ಬೇಸ್ ಜಂಕ್ಷನ್ ಮತ್ತೆ ಕಲೆಕ್ಟರ್ ಬೇಸ್ ಜಂಕ್ಷನ್ ಎರಡೂನು ನನಗೆ ರಿವರ್ಸ್ ಬಯಾಸ್ ಆಗಬೇಕು. ಎರಡೂ ರಿವರ್ಸ್ ಬಯಾಸ್ ಅಂದ್ರೆ ಓಪನ್ ಸ್ವಿಚ್ ತರ ಆದಾಗ, ಕಟ್ ಆಫ್ ರೀಜನ್ ಮತ್ತೆ ಸ್ಯಾಚುರೇಷನ್ ಎರಡರಲ್ಲೂ ನನಗೆ ಸ್ವಿಚ್ ತರಾನೇ ವರ್ಕ್ ಆಗುತ್ತೆ ಟ್ರಾನ್ಸಿಸ್ಟರ್. ಆಕ್ಟಿವ್ ರೀಜನ್ ಅಂತ ಹೇಳಿದ್ರೆ ಆಂಪ್ಲಿಫೈಯರ್ ತರ ವರ್ಕ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಕಟ್ ಆಫ್ ರೀಜನ್ ಅಲ್ಲಿ ನಾನು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ನ ವರ್ಕ್ ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ both has to be reverse bias, both the junction, that is emitter based junction and the collector based junction has to be reverse bias, and here the transistor will be acting like a open switch. Saturation region ಅಲ್ಲಿ ನಾನು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ ಆವಾಗ both has to be forward bias, both the junctions has to be forward bias and the transistor will be acting like a closed switch. Now if I want my transistor to be used as an amplifier, then the emitter based junction has to be forward bias and the collector based junction has to be reverse bias. Anta region anna ನಾವು active region ಅಂತ ಕರಿತೀವಿ. Hope you are getting this. So emitter based junction forward bias, collector based junction reverse bias ಅಂದ್ರೆ ಈ region ನ ನಾವು active region ಅಂತ ಕರಿತೀವಿ. When both are forward bias, this is a saturation region, and both the junctions are reverse bias ಅಂದ್ರೆ ಇದನ್ನ ನಾವು cut off region ಅಂತ ಕರಿತೀವಿ. Okay, this is region of operation. ಏನಿದು ರೀಜನ್ ಸೆಲೆಕ್ಟ್ ಮಾಡೋದು ಅಂದ್ರೆ ಏನು ಅಂತಂದ್ರೆ ನಾವು ಇದನ್ನ ಸೆಕೆಂಡ್ ಇಯರ್ ನಲ್ಲಿ ಡೀಟೇಲ್ ಆಗಿ ಓದ್ತೀವಿ. ಇದ್ರ ಮೇಲೆನೆ ಒಂದು ಚಾಪ್ಟರ್ ಇದೆ, ಕಂಪ್ಲೀಟ್ ಚಾಪ್ಟರ್. there will be getting a complete idea what exactly is this active region. Okay na? So this is the output characteristics and input characteristics of a transistor. After this comes the applications of this transistor, few applications of this transistor. One of the application of this transistor is a photo transistor. Photo, something which is related to light. So this is the symbol of a photo transistor. This is the symbol of a simple transistor. Photo transistor and the light is made to fall on this. So this transistor will be turned on will be operated when light falls on it. As usual, this photo transistor ಗೆ ನನಗೆ 3 ಟರ್ಮಿನಲ್ಸ್ ಹೇಗಿದೆಯೋ ಅದೇ ತರ ಇದರಲ್ಲೂ ಕೂಡ ನನಗೆ 3 ಟರ್ಮಿನಲ್ಸ್ as usual ಇರುತ್ತೆ. And as soon as the light is made to fall on this, in spite of me biasing the junctions, the transistor will not be conducting until and unless the light is made to fall on this. So photo transistor, this transistor responds only when the light falls on this. ಅದಕ್ಕೆ ಅದನ್ನ photo transistors ಅಂತ ಕರಿತೀವಿ. ಏನು ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಫೋಟೋ ಟ್ರಾನ್ಸಿಸ್ಟರ್? ನಾವು ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ನಲ್ಲಿ ಒಂದು ನೋಡಿದ್ವಿ, ನೆನಪಿದೆ? ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ನಲ್ಲಿ ಐ ಬಿ ಟೇಕಿಂಗ್ 2 ಕಾಯಿಲ್ಸ್ ವಿಚ್ ವಿಲ್ ನಾಟ್ ಬಿ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ಈಚ್ ಅದರ್. 2 ಕಾಯಿಲ್ಸ್ಗೆ ನನಗೆ ಕಾಂಟ್ಯಾಕ್ಟೇ ಇರಲ್ಲ, ಬಟ್ ಸ್ಟಿಲ್ ಪ್ರೈಮರಿ ವೈಂಡಿಂಗ್ ಗೆ ನಾನು ಸಪ್ಲೈ ಕೊಟ್ಟಿದ ತಕ್ಷಣ ಸೆಕೆಂಡರಿ ವೈಂಡಿಂಗ್ ನಲ್ಲಿ ನನಗೆ ಕರೆಂಟ್ ಕಂಡಕ್ಟ್ ಆಗುತ್ತೆ ಅಂತ. ದ ಸಿಮಿಲರ್ ವೇ ಇದನ್ನ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ದಿಸ್ ಇಸ್ ಅನ್ ಆಪ್ಟೋ ಕಪಲರ್. ದೇರ್ ವಿಲ್ ಬಿ ದ ಕನೆಕ್ಷನ್. ಇಲ್ಲಿ 2, ದಿಸ್ ಇಸ್ ಇದು ಆಕ್ಚುಲಿ LED ಆಗ್ಬೇಕು. ಇದು LED, ಇದು ಫೋಟೋ ಟ್ರಾನ್ಸಿಸ್ಟರ್. ವೆನೆವರ್ ಇಲ್ಲಿ LED ಮಾತ್ರ ನಾನು ಸಪ್ಲೈ ಕೊಡ್ತೀನಿ. ಫೋಟೋ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಗೆ ವಿ ಆರ್ ನಾಟ್ ಗಿವಿಂಗ್ ಎನಿ ಕೈಂಡ್ ಆಫ್ ಸಪ್ಲೈ. But optocoupler, there is a coupling, there is a connection between these two terminals, these two components. One is LED, the other one is a photo transistor. What kind of coupling? Opto, that is something which is related to light. ನಾನು ಸಪ್ಲೈನ ಈ LED ಮಾತ್ರ ಕೊಡ್ತೀನಿ. So once when the LED starts emitting the light, only then the phototransistor starts to respond. ಈ phototransistor ನನಗೆ ವರ್ಕ್ ಆಗಬೇಕು ಅಂದರೆ LED ಇಂದ ಬರ್ತಾ ಇರುವಂಥ ಲೈಟು ಈ phototransistor ಮೇಲೆ ಬೀಳಬೇಕು. So there is a connection between, connection ಅಂದರೆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕನೆಕ್ಷನ್ ಇಲ್ಲ, there is an optical connection between the LED, ಇದು LED ಅಂತ ತಗೋತೀವಿ, ಲೈಟ್ ಸೋರ್ಸ್ ಅಂತ ತಗೋತೀವಿ, ಆ್ಯಂಡ್ ಇದು ಫೋಟೋ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಆರ್ ಅ ಫೋಟೋ ಡಯೋಡ್ ಆಗಿರ್ಬೋದು. ಓಕೆನಾ. ಸೊ ಇನ್ನು ಆಪ್ಟೋಕಪ್ಲರ್ ಅಪ್ಲಿಕೇಶನ್ಸು ನಾನು ನೋಟ್ಸಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀನಿ, ಅದನ್ನು ನೋಡ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್ IR ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್. IR ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಅಂದರೆ ಇನ್ಫ್ರಾರೆಡ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ರಿಸೀವರ್ಸ್. ಸೊ ಇದು ನಾವು ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ ಅಂದರೆ ನಾವು ಟಿವಿನಲ್ಲಿ IR ಟ್ರಾನ್ಸ್ಮಿಟರ್ಸ್ ಮತ್ತು IR ರಿಸೀವರ್ಸ್. IR ಟ್ರಾನ್ಸ್ಮಿಟರ್ಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ಎಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಮ ರಿಮೋಟ್ ಕಂಟ್ರೋಲಲ್ಲಿ, ಆ್ಯಂಡ್ ಟಿವಿ ಎಂಡಲ್ಲಿ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ IR ರಿಸೀವರ್ಸ್. IR ಅಂತ ಬಂದಾಗ ವಿಲ್ ನಾಟ್ ಬಿ ರೈಟಿಂಗ್ ದ ಸ್ಟ್ರೇಟ್ ಲೈನ್ಸ್. LED ಅಥವಾ ಫೋಟೋ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ಗೆ ನಾವು ಈ ಥರ ಸ್ಟ್ರೇಟ್ ಲೈನ್ಸ್ನ ಬರಿತೀವಿ. IR ಅಂತ ಹೇಳಿದಾಗ ಇನ್ಫ್ರಾರೆಡ್ ಲೈಟ್ಸ್ ಅಂತ ಹೇಳಿದಾಗ ವಿಲ್ ಬಿ ರೈಟಿಂಗ್ ದ ಆರೋ ಮಾರ್ಕ್ಸ್ ಲೈಕ್ ದಿಸ್. ಸೊ IR ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಆರ್ ದ IR ರಿಸೀವರ್ಸ್ ಸಿಂಬಲ್ ಹೀಗೆ. IR ರಿಸೀವರ್ಸ್ ಅಲ್ವಾ ಇದು. ಸೊ ನನಗೆ ಲೈಟ್ ವಿಲ್ ಬಿ ಮೇಡ್ ಟು ಫಾಲ್ ಆನ್ ದಿಸ್. It is receiving the IR lights. So this is the symbol of IR receivers. IR transmitters also are there. IR transmitters andre illinda light horgade hogutte. So this is the basic difference between IR transmitters and IR receivers. So this is the end of this chapter, bipolar junction transistors. Okay. So if you are having any doubt, please do call me and ask. Okay. Thank you.